doxings. All right. Um, okay, so I thought I would start with I'm running the dev branch right now. This is probably really hard to see. Um, just so we can do a really quick overview, reminder of how the whole flow works, just starting from the controller. And just make sure you guys can see my VS Code here.
It's good.
Okay. And yeah, just give a yell anytime you have a question or I'm not showing what I think I'm showing, or you can't, read my screen or whatever. Um, and so okay, so the goal here is to go through my pull request for doing flow-based test scenarios. Um, just high level in the description, um, I say that this is like Selenium website testing. So if you're not familiar with Selenium, it's kind of just what we what this sounds like. You're creating a flow, a sequence of events, and in Selenium, it's for a website. So click on login, you should see the login screen. Enter username and password, you should see the logged in user area. So it's basically black box testing for the most part, where the test scenario doesn't know the internal details necessarily,
Mhm.
but it's just saying, our flow diagram says you should get to this next screen if everything's working right. Uh, our tests are going to be a little bit deeper than black box testing, where we'll occasionally dive into the details inside the box and say, look at data stored within the controller during a test. Um, but the basic idea is that it's like click to click testing, but in our SeedSigner context. Um, so by way of review, I want to just see if we can quickly write some pseudocode. So a controller, let me slide this over. The controller's job is to run the universe for us. So instantiate some objects, blah blah blah. Um, and then when we finally get to start, all right, it's going to show our opening splash screen. It's going to set up our quote next destination, but when it first runs for the first time, there is no next, so it's just kind of the
Mhm.
initial destination, and the initial is just the main menu view. So controller, what does it do? And again, this is just pseudocode. Um, create initial destination, which we know is the whoops
In menu code,
main
yep.
menu view. All right. And it's going to run forever in a loop where it's picking up the next destination. Um, and the only thing that really matters is it's going to run that next destination. So, uh, infinite while loop, next destination, run. So, what is happening inside that run? So, the next destination is a destination object. Let's see, where is that defined? All right, a destination has some member variables, and its run is going to instantiate some some view class, and call the views run. So we're going deeper into the hierarchy. So destination.run is doing instantiate view and then call the view.run. And what
We've
is
got
that doing? Yeah, sorry, go ahead.
on line 5, can you just reference the file there? That is views.destination.run.
Yeah, let's see. So that would be, this is in, right, view.py in the destination object.
Mm-hmm.
And we are line 96. So that would be, oops. And
There we
then
go.
when I switch branches, these line numbers, will
Mm.
change, but at least it's a starting point.
Yep.
Um, and then let's look at the view. So a generic view, let's see, where's that? It's at the top.
Sorry if you already clarified this, but we're looking at pre-PR, correct? Is that
Correct. Yeah. So this is
all
just
right? Thank you.
the dev branch.
Dev branch. Yep.
No alterations.
Excellent.
Um, so the run is going to be different in each individual view class. So we can look at the main menu view. I gotta stop scrolling with this mouse. The mouse wheel scrolling on Mac is just so counterintuitive. Um, okay, so then this is one of our example views, the main menu. Its run is going to do whatever work it needs to do. So it's setting up the menu items that it's going to offer. It's instantiating a screen that it needs to generate in order to display itself to the user. And then it calls display. So let's go back to our notes here. So within the view.run, do some setup for itself, instantiate its screen, which may be a generic screen, may be specific to that view. So in the main menu case, the screen is just a generic large button screen. We give it the configuration info it needs, button data selections for what options are available, and then we call the screen's display. So then we go screen dot display. And then of course that's going to do extra work, run to the screen, listen for user input. And then the most important thing that it's going to do is return the user's selection. So when we call screen.display, at this point, the view code just waits. So it could be waiting for, if you put the SeedSigner down and don't make any selection, it's just sitting here forever until you finally click to select which of these menu items you want. When you finally click, you've returned your selection, and then the view moves on to return the next destination based on your user selection. So the view now receives the user's selection, and then the view creates the next destination and returns that destination to the controller. So again, with the main menu view, we've selected whichever item, scans, tools, settings, whichever, and we're returning that as a destination, and that's being returned to the controller as its next destination. Or sorry, it would be down here. So from the run, from the views or destination run. So actually, let me back up here. Returns that destination to the it's kind of like to its calling destination, right? So if we look at here, right, because this is what we started from. And so now if we kind of back out, you've received the next destination from the view. Return next destination to the controller. It should kind of be like that. There we go. And then controller receives its next destination. Okay. I mean, these last steps, it's just they kind of just happen. It's just passing the buck back up the chain so that the controller can now do its next step in its infinite loop to run its next destination. And we can even do it like that. Okay, so this is just the very high level infinite loop of how SeedSigner displays a page, receives user input, and then feeds it back into the next screen to display. And we've just basically covered all the details, except we don't care what happens inside the actual screen class, which is going to be rendering the pixels to the screen, because that's what we're going to be mocking out in my pull request. This is the part that we're going to be skipping over, basically. All that matters is that we need to return the user's selection somehow, as if the screen ran and as if the user provided us input. Okay. Any questions on those basics so far?
I guess I'll add that this is like the happy path, right? This is the most common path. Like there's always edge cases that don't follow this exactly, right? Like if you like the screensaver or if you back out kind of thing, it's a little bit different, right?
Yeah, yeah. Although even the if you hit the back button, there
Yeah, it's
is
easier.
a, let's see, what is it called? Is it backstack view?
Backstack.
Mm-hmm.
Right. So even when you click the back button and it is a special case, it is still, oh, that should derive from view. That's interesting. Um, I mean, I think we have a special check for that. Yeah. So if the next destinations class is a backstack view, then we handle it a little bit differently in the controller. But philosophically, it's the same thing. The user selection could be
Going back.
go back. Right.
Mhm.
And so then in that case, when the view creates the next destination, it would create the destination where the view class equals, oh, that was interesting, equals backstack view. So even though the backstack is a special case, it still fits within the standard flow of steps here. And then the other possibility is that, what if there's an exception in the code that gets raised in the screen? Like we have a bug. Then the controller also has some mechanisms for catching exceptions and routing them accordingly. Whether the bug is in the screen itself or when the view inside any aspect of the view running, it'll catch that exception.
Is that try catch in the it's in controller, isn't it?
Yeah, so
Or is
it's
it in
wrapped
the actual
around
screen? Yes, there's a
running
try
the
catch in
destination.
controller.
Yeah, yeah. So in our pseudocode, that would basically encapsulate any error that happens
Mm-hmm.
in that block.
Yep.
All right, so now let me swap back to my PR branch and pull back my stashed changes. Okay, so now
And this is
let's
PR
look.
339, right? Oh yeah, it's right there in the screen. Perfect.
Yes, 339. So I want to look at the differences, and this diff view isn't the best, but it's kind of the best we can do for now. I want to get to the controller changes. Here we go. So I'm not going to worry about the stop controller command yet. The first change, and I'll go back and forth between the actual code and the diff. So in the controller, now that we're in the modified branch, the start, which is the beginning of this infinite loop, now takes an optional initial destination. So we said originally, when we create, before we start the infinite loop, we have to give it an initial destination. And that previously always defaulted to main menu view.
Mm-hmm.
In this updated version, if you supply an initial destination, okay, big surprise. That's what gets used as our quote next destination, even though it's really the first destination. But the default behavior is still what we had before. Just use the main menu view if it's like the first time we're booting up the device. So, and you'll see why we need to be able to offer that as an option. But the default is still just to generate the main menu view. Okay. Again, I'm not going to go into the stop controller command just yet. And that's it for the controller. So all we did for now is add the ability to change where the controller is going to start itself. Let me find the next thing. There we go. View. Okay, so in the basic definition of a view, so let me go back to the code. So in view.py, in our definition of this core base view object, we have this new function called run screen that did not exist before. And what it's doing is it's instantiating our screen and it's calling display. So we had that. We instantiated our screen and we called display. The difference is that those two steps, so all of this, instantiate the screen, call display, and return the user selection. That happened inside the view.run previously. But so now that's happening inside view.run screen. And actually, you know, let me save a version of this before and after. All right, so that's the before. And then this will be the after. Oh man, the syntax highlighting. Hang on. This is not Python. This is, I'll call it Markdown, whatever. And I'll post this up as a GitHub gist so we can review it later. So now we're gonna have a view.run screen call, and its job is to do that. And then it's going to return the user's selection. Oops. Okay, so this is new. So maybe I should do like that. Like that's a new piece for this PR. So let's look at how.
Could I just ask you for a second? Let's just have a look at the PR because I actually haven't read the latest on the PR. The PR originally was to build the test scenario, build the tests for that. So we're doing modifications that facilitate that testing suite to now occur. And I guess that's going to be an automated test as well, to some degree.
Yeah, so let's see.
And
yeah, actually,
jumping ahead or behind.
No, you know what, you're right. I think we're getting too much into the details here, and I should back out just to look at what yeah, let's rearrange the order of how I was thinking about this. So let's not even look at any implementation details. Let's just see like an example of an end result. So there is a new test flows test class or test file.
Mm-hmm.
And you can kind of see the naming convention I'm using here. So test the flows for the seed module, the settings module, the tools, the more generic higher level views. And then this test flows is like test the basic concept of a flow-based test itself, right?
Got
So
it.
like
Yep.
test the mechanism that enables these flow-based tests. And so here's the first one: test a simple flow, where I'm going to say, okay, I've declared a flow testing class. So that's my base testing class that I'm going to use for all of these flow-based tests. And it's got built into it a function called run sequence. That's where the magic is happening.
Mm-hmm.
And I'm just going to define a sequence as a series of flow steps. So in this case, each flow step is a separate screen that you would see on SeedSigner, or it's a separate user input activity that you would take
Got it. Mm-hmm.
through a flow. And the flow step has an expected view. So which view is going to be run for this step? And then some options. But for now, the most important one is screen return value. So that's this wait for the user selection. Which option did they select?
Got it.
Or I'm sorry, rather button data selection. My mistake. And so this very simple sequence is, we started at the main menu view as if the SeedSigner just booted up, and the user is going to select tools. If they select tools, we expect them to land at the tools menu view. From there, they're going to select keyboard. Well, what is keyboard? If we look at how it's defined, that's the tools option to calculate the final word. So the tools menu view is for creating new seeds. Image entropy, dice entropy, picking words out of a hat. And then we kind of shove the address explorer in there too. So in this test, we're going to test typing in 11 words and then calculating the 12th one. Let's see, where am I? Test flows. Nope, sorry, I'm getting myself lost here. Test flows. Okay, so we said we're going to type in 11 mnemonic words, and SeedSigner, you're going to calculate the last word for us. And so the first view, once we've made that selection, is we need to ask you, oh, are you going to give us 12 words or are you going to give us 25? So that's the calc final word. That's kind of the end of that chunk.
Mm-hmm.
And then number words view. So this is the prompt to ask, are you going to give us 24 or 12 words? And the user is going to say, oh, I'm going to give you 12 words. And so then the next one is the keyboard entry, where you start typing in your first mnemonic word. And again, this is just testing a simple flow. So we're not going to go through the entire sequence. We just want to know that we went from A to B to C to D, and we landed on the views that we expected. And so at this point, we're satisfied. So we're going to say, you know what? Upon confirming that this is the view that we actually landed on at the end of this short sequence, now we're going to stop the controller and just call this test done and successful. So the stop controller command, because otherwise the SeedSigner will just wait forever on this mnemonic entry view. It'll be like, okay, what's your first seed word? And it's just waiting for an answer. So rather than giving it an answer, rather than saying my first word is Satoshi, we're just going to raise this exception, this stop controller command, that's only used for these flow-based tests. And the stop controller command is so complicated. I mean, it's just a nothing, right? It's just an exception, but it's a special exception that is only used by the test suite. But there's absolutely nothing special about it other than the fact that it's a custom class, just for the purposes of being explicit that this is for the test suite, and it's how the test suite signals that the flow-based test is done. And actually, maybe I could have used a better name for this. Maybe it's like stop flow based test command, right? Like that's probably a better name for it. It's just more explicit. So
Yeah, because it doesn't actually stop the controller.
yeah, well, it does, but if we look at the controller code, um, so the beauty of VS Code, my change has already been made, and then in the controller, it does still do that try except to catch any exceptions, but it now has, so this is that destination.run, but it now has a carve out specifically for the test suite. And then lots of code comments. So the majority of this pull request is by far, it's more code comments than code, just because I want to like be very clear about, what all these steps are doing, especially for a change like this where it's creating an intrusion upon the main code base that, it um if I did something crappy in my changes here, I could create a bug that affects, the core functionality of SeedSigner, even outside of the test suite. So it's a little unusual to have code specific for the test suite, but I need certain hooks. And so I couldn't find any way around that. Although there, who knows, there may be ways to avoid modifying the controller in this way just to have support for the test suite. Okay.
Great. Thanks for the overview.
Let's see. I'm just reading. Yeah, I think.
Do you think
I'll
you'll
have to.
keep that name change of the stop flow based test command?
I think so. I mean, I think it's more explicit because before that, it was
Then
stop
change the
controller.
print. Yeah, there you go. Yeah, I don't know if you
Yeah.
want to update that now or anyway. It doesn't matter.
Yeah, but it's just if when it was in this form,
Hmm.
if you didn't know anything about the test suite, you'd be like, "Oh, what does stop controller do?" Right?
Yeah.
It like leads you down the wrong rabbit hole where it's like you see the word test, so at least that gives you a hint.
Yep, totally agree. I think it's a way better name, like you just said. I agree with
Yeah.
all your points.
Okay, so now let's go back. So that was just a basic run sequence. So what else can this flow testing class do? Well, we're telling it all the views that we expect to land on. So what does it do when we land on the wrong view? So of course we set up a wrong view test. So we're going to say from the main menu view, we're going to choose to go to the power off options. Except we're going to write this sequence as if we expect it to go to the tools menu view. But hey, that's wrong. It should raise an error. And so we have a custom error of flow did not expect view. And again, maybe I can make, oh, you know what? I did have a problem here. So go to the definition of this assertion. I initially named this test flow did not expect view, just to be like consistent. But unfortunately, with PyTest, if you start something with test, you create problems for yourself. So,
Yeah.
maybe if I rearrange the phrasing here, but yeah, so that's the reason why it doesn't start with the word test. But so this is a confirmation exception. Like we expect our sequence to raise this like unexpected view error because
And we're
it's the
testing the
wrong view.
test.
Exactly. And so in the real world, if a future change altered a flow or broke a flow and we landed somewhere else, then it would be like, wait a minute, we didn't end up where we expected, raise an error. And then that would be like the way the test suite is supposed to work. That like, oh crap, I broke something in the routing and now we're landing in the wrong view. But hey, cool, the test suite caught that we broke the routing. But yeah, so in this case, we're just intentionally creating a sequence to trigger that. This one gets more complicated. So, imagine the scan view. So we're going to test reading in a seed QR from the camera. But what we've done actually, let me go to the base test class here. I'm able to run this on my MacBook with none of the Raspberry Pi dependencies installed. You can't install the Raspberry Pi hardware dependency modules on the MacBook. And so the only way that I can run the SeedSigner code is if I mock out the hardware dependencies, because as soon as it tries to import these dependencies, it's going to crash because they aren't installed on my MacBook. And so anything that's hardware dependent has to be mocked out as the very first thing that the test suite runs. And so what this is doing is it's basically saying, hey, when you try to import this, instead of really importing it, just mock it out. And that's what magic mock does. It just says, so from this point on, anytime the Python code asks for the renderer object, it'll return this magic mock that's like pretending. It's like, yep, here's the renderer. Here it is. It's totally the real renderer. And then if I call a function within the renderer and again, the magic mock, it doesn't even know anything about it. It's just like, yep, here's that function you asked for. And it just like returns nothing. So it just patches out any of these dependencies that I can't actually run for real. Okay, but so in this case, there are going to be scenarios where we need to do things like access the camera, and we just can't do that. So what this run before option provides in a flow step is, hey, if you need to kind of fake something or insert some data or insert some result, you can go ahead and do that there. So this basic test isn't the best example. Let me jump to the seed. So here it is, test scan seed QR flow. So our run before step is going to be load a seed into the decoder. So if we look at the scan view does a lot of work. Let's see.
Yeah, it does the whole decode the QR back into self-decoder. Yep.
Every QR. So not just seeds, but PSBTs, settings QR, wallet descriptor QRs, multi-sig descriptor QRs, single address QRs. I don't know what it is, QRs, right? But since we can't actually have it look at anything, we don't even have a camera right now in the test suite. So we just have to fool the scan view here to think that its decoder did actually receive some data. And in this case, it's going to be a seed QR. And so when we're testing it, we just have to inject into that into this scan views decoder this seed QR data. And so then let's see if we can get there. So add data. So based on the data type, it figures out, what am I looking at? What type of QR is it? Is it a seed QR? Is it a PSBT QR? Whatever. And we're giving it data that looks like a seed QR. And so then the decoder can then say, oh, I recognize this data format. It's a seed QR. And then it does everything we need. But we just have to inject that into the decoder ourselves manually before the scan view tries to run. So I know that was a lot to like throw at you all at once. But so we instantiate the scan view. and it has a decoder that's waiting to do something. Normally, when we run the screen, that's just turning on the camera, and the scan screen is waiting to see a PSBT and then feed that PSBT data into a decoder. And then when the decoder has received a full QR, this screen exits, and now the decoder is enriched with data. And so if we can just skip this run screen step and jump straight to saying, hey, decoder, what do you have? Then we've got it. And so that's what the this test is accomplishing. So we're saying, okay, start from the main menu, pick scan. In theory, that would turn on the camera. We're injecting our seed QR data into the decoder. The way that the one of the details we haven't looked at yet, but this run screen call gets mocked out entirely. It just does not run in the test suite. So that's how we can get away with this. We're skipping the part that would have invoked the camera.
Because the hardware doesn't exist.
Exactly.
Mhm.
But we're still
And
supplying the decoder with all the data it would have received from the camera.
And does that happen anytime you define run before? Does it skip the run screen? Is that what happens?
The flow-based test will always skip all the run
Always.
screens, because
Okay, thank you.
even the main menu view, its run screen is just going to paint the pixels onto the display, and we don't have an ST7787 driver, to draw pixels to. So we can't even allow a normal view to just draw a simple screen because there's no hardware to draw to. It'll just crash again. And then now that we know that we've loaded a seed QR, we expect to land on the seed finalize view. This is where it asks, do you want to add a passphrase or not? We say no, just finalize it. And then we should land on the seed options view, because now our seed has been loaded, and now we can stop and end this test. Okay, and so now this is a simpler version, a simpler task for run before. And so we just want to see that run before had an effect on our view. So this is a dumb test. It's going to say, rather than let the main menu view supply its 4 input options on that main screen, we're going to say, hey, run the main menu view with no options on screen. We're just blanking its button data. But we're still going to say, oh, by the way, the user selected tools. But because we've blanked button data, there is no such thing as a tools option in this run of the main menu view. And so that should cause an exception, because the main menu view will be like, what the hell? There is no such selection called tools. And so we expect to land on the unhandled exception view. But this is all just a way to test that this run before really did alter the view, and it had the expected outcome of altering the view. If run before did nothing and the user selected tools, we would successfully go to the tools option, or the tools view.
And so the
Mhm.
flow test itself is, as I just said it, I realized we're only testing the menu flow. We're only testing that sequence of where we expect to land up. We're not testing whether the QR code was able to successfully decode a Spectre QR.
Right. Like, because we still have dedicated test classes for other things. I don't know if we have. I'm looking
There's
now.
one for a compact seed QR. Perfect.
Yeah. So this is more like the So going back to the PR, let's see. So when the PR says that these flow-based tests are like Selenium website testing, that's what I mean by black box testing. We're not worrying about the details necessarily of did it read the seed QR correctly? We're just asking, did we land on the next step, assuming it was a valid seed QR? And then we still have specific tests to go into, the details within that black box.
Got
So
it.
these more specific tests, they do know all the details to the point where they're trying to find, like just by passing a seed QR with this exact byte, will it crash? Right? Like that's like so detailed. Like no user would ever, be aware of this level of detail, right? So we still have these specific tests.
Great.
All right, and then so we do know that the back button is special because there is a whole back stack within the controller. And so we just want to have a basic test that tests what happens when the user specifies the back button. So we go to the power options, we land in the power options, we click back, we expect to end up back at the main menu view, stop. Super simple. Just a trivial test that we are handling back button commands as well. And then another trivial test that we can specify an initial destination to start the controller with so that it's not starting at main menu view. So let's see. Okay, so let's see. I'm going to say jump straight to the calculating the final word. And so we had seen this view above. This is the one that asks like, okay, you want to calculate your final word? Are you going to give me 12 words? Or are you going to give me 24 words? So I can jump straight there. There's no dependencies on that view. That view doesn't need any other information other than the user wants to view it. So as long as we can have that be the first step of the flow, behind the scenes, it'll pass that as the initial destination into the controller. And then we can just stop right from there. We don't have to do anything more just to make sure that the controller did launch itself and we did receive this view. It did not go through the main menu view. So that one's trivial. But now, what if it's a more complicated view that needs input arguments to do anything? So like in this example, if we want to start on the seed options view, we need a seed number. We need a seed in the controller in memory, and we need to give the seed options view the index number of which seed we want to look at the options for. So we have to do some setup work. We have to create the seed, set it, finalize it. Now it's in memory as index seed position 0. And so we can say, okay, start at the seed options view, but we do have to give it its input arguments, which is, oh, you're operating on seed number 0. And we just confirm that it doesn't complain. Like if we didn't, actually we can do this. So if I just run the whole test suite now, good, everything runs. If we don't provide the input argument for seed options view, let's see what happens. We're missing an argument. We need the seed number. All right, so this just supplies that
Very
into.
nice. Yep. Got it.
Okay. And then we also want to make sure that we can catch any unexpected exceptions. So again, this is the test suite, doing what we wanted to do. So, or rather, let me restate that. In this case, we want to test, can we force the test suite to raise an exception and have the normal controller loop catch it and process it the way we'd expect it to. So this unhandled exception view is part of the controller's normal procedure. When it finds a generic exception, it's going to handle that exception. And in handling it, it's going to send us to the unhandled exception view. So this is the view that shows up on screen that says like, oh, there was a problem, and it spits out some debugging, like the line number and the
Yep.
file name. So we just want to make sure that that we land there if any arbitrary screen or view throws an exception. And so this is just a simple test. Run the main menu view, but pretend an exception occurred, and just verify that we've gone where we expect to go. So these are the basic tools that these flow-based tests can use. So now, and thank you, Mark. Now let's look at how this is implemented. So now that you understand, what we can do with this, let's see how we got that wired up. So I'm in the base class or the base file within the test directory. Like I said, we're mocking out anything hardware level, any hardware dependencies. And we have, let's get to here. We have our flow test. So like I said, the flow test runs a sequence. Sequence is a list of flow steps. And so now this is like the most complicated part. So actually, let me take one more diversion before we dive into that. We'll just do a very quick intro to mocks and patches. So make this even bigger. So let's say we've got, I was mocking this up or practicing this myself early this morning, so I've already got written. All right, so really simple function, add A to B. So that's just going to be return A plus B. Cool. So we do add 5 plus 7, 5 and 7, we get 12. Awesome. But what we can do with patch is we can say with patch. So we already got most of this written. We're going to patch this add function. I have to do this import a little bit funky just because of the way that it works within this namespace. We're going to patch my add function as add. And then this as is just to give me a variable to work with. So I can alter it. And I'm going to say, you know what, no matter what, its return value is always going to be 8. So I don't care what inputs you give me, I'm patching it to always return 8. So now when I call add 5 and 7, oh, I have to do it within my width, within my context. Oh, and I need to show my result. Print. There we go, 8. So the unpatched version gives me 12. And then while the patch with context is active, I get 8. So this is like one of the core principles of how these flow-based tests are working, where in this case, we're just forcing a return value to whatever we want it to be. So where this comes into play is, go to our basic test flows. We want our selection from the main menu screen to have the user return tools. So, the parallel here would be like, okay, we define a constant. Tools equals, it's the option, the 1th index. And so now in my patch, I can just say, okay, return tools. And so now it's going to return 1, right? Because I've patched my function to only return tools in that case. And so I can just go step by step, and I'm basically just patching these outputs. So I don't care what the screen would have returned. If it could run, it doesn't matter. I'm just going to force it to always give me, whatever specific output return value I want to give it. And so if we look at, let's see. Okay, hang on. Here we go. I'm patching in the same way I did down here. Well, let me do this one. Sorry, I'm going out of order here, but I'm trying to keep it sane. um, so we have this view.run screen. So let's look, what does view.run screen do? So this is this new function that instantiates the screen, calls display, and returns the user's selection from that screen. So in the main menu view, we're going to instantiate the main menu screen, which shows the 4 buttons. We're going to wait for user input, and then we're going to return the user selection. Like they clicked the tools button. So that's what run screen is doing. So in our test flow, we're going to mock that entire run screen function. And we're going to get a side effect. So this is a new concept. A side effect is basically, instead of just specifying hard coding a return value, we're going to say run the function that we supply you. So run a function called next return value. So what does this function do? It's figuring out what the return value should be based on our sequence. So, okay, grab the next flow step off of our sequence. And skipping some details, we can return the screen value. So again, going back to our test. Well, okay. There's no way around this. So I'm sorry, this part is very it's a bit disjoint. It's a little hard to jump around and explain all these steps clearly. So I'm not doing the best job here.
No, you're doing great.
Yeah,
but
let's
look at the main menu view. I would be confused if I was listening to this explanation for the first time. So I appreciate your patience and concentration on this. So let's compare the before and after on view.py in the definition of the main menu view. Let's see, main menu view. Okay, so before, inside the run, main menu view was saying, oh, I've got these 4 menu items, feed those into my screen. Now we have a change where those 4 menu items are being defined in the class, basically as like class-wide constants. Yeah, so they're not buried inside the run. Right, they're above. And so button data is the collection of options that we're going to give to the screen. So we define each option, and then we collect them into a list. And then button data is just passed straight in to our screen. So that's
really nice.
Right. So now, and then here's this change, right? So here's the change we just looked at. And so by defining these as constants within the class, including the button data, in our flow, we can now say, here we go. We can now say main menu.tools is the button that we want to pick. Whereas before this change, there was no such thing as main menu.tools. It was
generic.
Here. It was just shoved in. Yeah, it was just shoved into this list. It wasn't, you couldn't pull it out on its own. So it's just providing access to it from the outside, which is what we need.
Mm-hmm.
Yeah, that makes sense when it's a constant. If it's dynamically generated, which you can probably cover later, it'll be a little different, I imagine.
Exactly.
Yeah, okay, cool.
Yeah. And then you'll see that it's part of the reason why there's 2 options here. So we're saying the button selection is tools. And so that's saying we want this one. We want the tool selection out of your button data, which I can access from the outside. And so in that case, we have a button data selection in our flow step. And so we're going to say we have access to the view. And we're going to say, hey, grab your button data. I want to return the index of my selection. So it's literally just saying, I know main menu view. I know you have a member object called button data. And I know you have an option within there called tools. Return the index of that. So this is going to return 0, 1, 2. Right? So it's going to return index 2.
Mm-hmm.
So that is identical to running the screen and the user clicking on tools, and the selected menu number will be 2. Right? And all right, and so we can just return. So we're saying return the index of that selection. And so now, as far as the view is concerned, what's the index number? Oh, it returned index number 2. And so it can pull that out and do the next thing. And so basically from this run screen has now been mocked out. So as far as the view is concerned, when we run this as part of the test suite, it's as if we did that, right? That just never happened, but we do have main menu view dot tools. So this is effectively what we've done when we run this flow test. And so it can now proceed to do the right thing with that return value.
Got it.
So undo that before I forget. Okay. So that's the basic, simplest path here. We gave you which button to select. You selected it. You return the index. We're done. The other possibility is that there's a screen return value. So in this case, if we look at the view, so again, in what we just looked at was this scenario, right?
Mm-hmm.
But what about this scenario, right? We need to be able to return to signal that we're returning a value that is not contained within button data. This is not one of the options that you'll find inside button data. And more importantly, for when we want to test exceptions, actually, the main reason is when we want to test exceptions. So if we go back to where I was testing my exception class or test case, where is the raise exception? My screen return value is an exception. So in this case, if my screen return value is an exception, I need to raise it. So this is the only way that I could get forced exceptions to work in this way. I instantiated the exception in my definition of this step, but that doesn't accomplish anything. It's just you've created an object in Python. It doesn't care. But I need to actually raise that exception for it to trigger the normal exception handling code in the controller. So there's a special carve out here to look for these two. Well, this specific exception. Actually, I don't even know why I did that. This shouldn't be necessary, right? I don't know. Anyway, the whole point is just to raise it. And then if it's not an exception, then just go ahead and return it as is. So then in the case of the back button view, let's see, where was that? Back button. We said the screen return value was the code for back button. So it's not an exception. It passes through that and it just returns the result of run screen is the back button code. And so when our main menu view receives that, the result of this call is the back button code. well, this view, there's no back button to process. You can't go back from main menu. So this is a bad example. But here, yeah, the power options view says, oh, if your return code is the back button, okay, do your thing. So those are just the two outcomes that you can set in a flow. You can either say, select this button option that was sent to the screen, or just send this exact return value, or check for an exception. Okay, so that's outputting our return value. And then also, because we've mocked the view.run screen, we go back to our definition of run screen. That means we're never instantiating the screen. And we can't, because this instantiating the screen requires hardware-based display dependencies. And then display is what runs the screen and returns the user input. So this never happens in the test suite. It's just completely mocked out. Run screen is just like mocking out the add function here. The real add function never runs, and it just gets our mocked version, our patched version of it. So that's how we avoid the screen-based dependencies. So between mocking this out and protecting ourselves at import time, we've now eliminated any hardware dependencies. Okay, so let's go back to how this all comes together. So, and I started deeper in that, and now I can slowly kind of back out. So we're also mocking out this destination._run view. So let's see what that is. Destination_run view. So all it does is tell the view to run itself. So we're going to have to back out a little further here. When we look at our list of steps that we're doing, we have this destination.run. Okay. But now destination.run is broken into these two pieces: instantiate the view, run the view. If we look at, let's see.
You're basically taking one step, breaking into two so that you can inject a test suite in between the two, right?
Yes, exactly. Exactly. So now in our notes here, we can say, instantiate the view, run the view. Well, actually what it should be is, let's see, what are the calls? Instantiate view. There we go. This makes more sense. And it does. It instantiates the view. And then run view. And does that. And then all of these get bumped in like that. Okay. So yeah, and like Nick said, we needed to be able to instantiate the view first to allow us to inject, like in the scan QR, seed QR case, inject some data into that view before it actually runs. So in the previous version, when it was doing both of these in the same function at the same time, we didn't have an opportunity to interject in that way. So now we are mocking out the run view portion of it. So that's when we call the run. And we're going to run this function instead. So this function, if we're at the end of the sequence, just call stop. We're done. That's how we exit or raise this exception that signals to the controller, just stop. We finished our test. We're going to do our sanity check. Is our view class for this destination? So, and again, remember, we are in the destination object right now. Is the view class the view that we expected for this flow. If it's not, throw the exception. We're out of sequence. Something wrong happened. We landed in the wrong place. And then here's why we really, need to be able to inject ourselves here. The optional run before. I mean, it should almost be called run before run, or maybe just before run would be clearer. Actually, let me do that too, since we're live improving this PR before run. I don't know. Is that clearer?
Yeah.
So this is a callable. So if we look at the definition of a flow step, before run is a callable, which just means pass in a function. It's a callback. It's like a very JavaScripty kind of looking thing. Pass in a callback. And so we're going to say, invoke that function and pass in the view object so that it can modify the view. It's free to modify the view however it needs to. We'll look at, there's just some special redirect handling. And then even though we're mocking out the run screen, so I said that we're mocking out the instantiation of the screen and running its display. There are some views that after the fact, after the screen runs, it then reaches back into the screen to ask it something like for the settings, it'll ask, hey, where did you leave off? Which item was selected? Or something like that. Or what was your Y, or what was the Y coordinate of the selected button? Something only the screen would know. And so because some of those views do access their screen object, we've got to mock that object specifically so that, because that object doesn't really exist when we're running the test. The screen was never actually instantiated. So we have to give it a fake object for the view to ask, like, hey, what was your Y coordinate? And Magic Mock will be like, sure, whatever. It'll give it something so that Python doesn't crash. I think it's basically like a lazily instantiated object. So if the Python asks for the Y coordinate but never actually uses it, it's all good. And then the last thing we do, now that we've taken all these steps, now we tell the view to run itself because we've overridden the view.run. Let me find it again. Up here. No, sorry, we're in destination.run. So this run view, all it's doing is telling the view to run itself. So the last thing we do is, okay, now we can finally tell the view to run itself. But yeah, so exactly as Nick said, run view normally is trivial, but when we run the test suite, it's got a bunch of other work to do. Exit the test, throw an error if we're landed on the wrong view, inject a modifying function, handle auto redirect views, which we can look at that in a bit. Just some easy patching, and then we can finally run. So now, if we look at our sequence here, we've patched the destination's run view with everything we just talked about. And then the only reason these are nested, the second patch, is because we need both patches active at the same time. So I don't know, maybe there's a way to do it without nesting, but I need to patch two things. So this is the second thing I need to patch. Run screen so that we can handle our return values. All right. And so now that those two things are patched, we can now get our controller and tell it to start. So start in the controller is that very first step all the way back here. Start the controller, show the opening splash screen, set up our initial destination, and then start the infinite loop that runs the application. So now that we've patched everything we need to patch, we patch something in destination, we patch something in view. We can now run the controller. And so the nice thing about this is that the sequences that we're defining for these tests are running through the full controller loop, right? We're not the initial, the very early version of this code, of this test approach, cut out the controller entirely. But this latest version now runs everything through the controller. So it's a much more realistic, like full system set of tests. Let's see what else. And so run sequence. Oh, and so note that there's no loop in our flow-based test here. We're telling it to run a sequence. We pass in this list of flow steps. We patch what we need to patch, but the loop is all handled by the controller. So like just by calling start, that handles the loop, and then we exit our test thanks to our sequence is empty, and so we stop it. And that's why the controller needs this extra check for, oh, did you receive a flow-based test? A stop flow-based test command? Yes, you did. Just return, which just exits the infinite controller loop.
Got it.
All right, so let me pause there and for any questions.
Not a question per se, but won't you fix that? We changed the definition of run button run. And in the class definition, you had a comment which referred to the old spelling. Run before is now before run.
Let's see.
On line 81.
Okay. Yep. Okay. And then we could just look through a couple of the, so at this point, looking through the actual example should be fairly simple. So we already looked at scan seed QR flow. So we're mocking seed QR data and shoving that into the before run. So from main menu view, scan in our seed QR, finalize, land on seed options view. Testing the mnemonic entry flow. So in this case, we're going to enter our 12 or 24 words. So I'm creating a helper function because I want to do a couple different mnemonic tests here. So starting from the main menu view, go to seeds. And here's an instance of how this redirect action works. So right now, if you go to the seeds menu view, when you have no seeds loaded into memory, that view auto redirects you to the next step. So there's no return value. It just spits you right back out. And then, so just to keep the test flow sequence in sync, I need to tell it, hey, there's nothing to do here. Just pop yourself off of the sequence stack and move on. And confirm that we landed on the load seed view. And on load seed, it's going to ask, oh, are you going to load a 24-word seed, a 12-word seed? Are you going to do it some other way? And so we're just setting up ways to tell it which method we're going to use. It's either going to be typing a 12-word seed in or typing a 24-word seed in. And then we're actually testing the full sequence here. So we need to go through each seed mnemonic word entry screen and actually supply the word for that step. So for a 12-word seed, we're going to call this 12 times as we enter our full mnemonic. So that's this loop going on here. For every word in the mnemonic, add this to our flow, or add this to our sequence rather. And then once it's done, we should see the seed finalize view. Say we're going to choose the finalize option. We're not going to enter our passphrase. and we should land at seed options view. If we get there, stop. And now run that whole sequence. And so now that that helper function has been built, we can do that whole thing with a 12-word seed first, and then we can do it again with a 24-word seed. And just make sure that we end up through that whole flow where we expect to flow. And then it's pretty easy to do the same thing for an invalid mnemonic. So if our mnemonic is so it's blah 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 entering. Oh, so okay, so I've got a valid mnemonic here. I'm going to enter all except the last word of it, and then the last word I'm going to enter an incorrect word. Zoo is not the final word. It's supposed to be impact, but I'm going to enter zoo. And we expect to land on the mnemonic invalid view. And so now we're going to continue the sequence. We're going to say, okay, let's fix it. Let's edit our mnemonic. And our implementation forces you to enter all 12 words again. So enter the first n-1 words, and then enter the final word as zebra. So we did it wrong again. We should land once again at the invalid view, except this time we're going to say, okay, screw it, discard. This is a bad mnemonic. I can't figure out what the correct answer is. And that should dump you out to the main menu view. And now we're done. Right. So that,
Beautiful.
maybe
Wow.
this should have been, 2 separate tests, like, stop when you arrive at the invalid view, and then a separate test just to test the edit to return to it. But whatever. It's one long flow, fairly complicated.
So something I spent a fair amount of time in that flow the past few days. So that is just beautiful to be able to test that.
Yeah. And then here's an example I started writing to test the xpub export flow. I have it commented out because right now it's not done. So I wanted to show how to modify some existing views to be compatible with these tests. So to test export xpub, I don't want to start from main menu. I want to jump straight to having the seed already on board in memory. So this is similar to what we did earlier. We're taking the controller and we're injecting a seed. So now we have one seed on board.
Mhm.
We have to provide its view argument. So we're going to operate on the 0th seed, and we're going to jump straight to the seed options view operating on the 0th seed. And we're going to select the export xpub option. So that should take us to the where it asks, are we doing single sig or are we doing multi-sig? And we need to say, we're going to, let's say we're going to, let's say we're going to specify single sig. So let's go look at that. Okay, so we want to specify single sig, but this view hasn't been modified yet. These definitions are buried inside the run. It's nicely organized, so all I need to do is promote them to class-wide level. So now that I can directly access single sig in this way. So I can go back to my test, and I can say my button data selection is going to be a member of this view, and I want single sig. Okay. So I've selected single sig, and then I need to fix up the rest of this view because I've pulled this out. Run was used to having them be local variables. So now they are internal attributes.
Yeah.
And I think true correctness would actually be referencing these constants with self feels a little ugly. I feel like the cleanest thing would actually be to do that.
Yeah,
Um,
because they're class level, not instance level.
yeah, and
Right.
arguably even here.
Yeah.
Um, but it's just, I mean, it's getting
Yeah.
it's making the lines pretty long. So for now, I've taken this approach just to make the
Yeah.
code look as similar as possible as to how it used to look.
It doesn't make it
Um,
any harder to read this way. So it makes it easier to
yeah,
read, in my opinion. So
yeah, right. It's just a little weird to see a self reference to a constant, but
yeah.
okay, I'm okay with that. If a Python purist takes over the project at some point, then they can fix my um, what's the word, heresy.
Yeah.
You could make a comment and say, I put this in here for you to find. Well done, you found my golden nugget.
Yeah.
Well, but I mean, this is like, so this becomes the new like coding convention that's going to be like everywhere, right? Because I've already modified this view. Um, so it's just like, yeah, if you got problems with it, you got a lot of search and replacing to do. Um,
We'll just change your SeedSigner title. You're not just lead dev, but you're Python heretic.
yeah, there we go. um, okay, so for single sig, um, and then the nice thing about doing all of this through the controller is our next view in the sequence is which script type. So are we doing, Taproot? Are we doing native SegWit, nested SegWit, whatever, custom derivation path? Um, because we're doing all of this through the controller, we don't have to worry about handling these view arguments for the next view ourselves. So I did have to do that for the very first view in the sequence because I had to start it off with the input arguments that it needs. But now that we're in the flow of the controller managing all of this, it always manages these view arguments for us. So there's nothing special that we need to insert here. The view is going to generate these view arguments, pass it on to the next view. That view will have them available to it, and it can just kind of carry on with life. So this is the next view that we're expecting. So continue our sequence. And here's GitHub Copilot trying to guess what I want it to do. And I mean, it's never seen the function or the view that we're expecting to land on, so it's just guessing. Um, although this is a decent guess that we're done with this flow once the next view is popped up. So I'll accept your suggestion. I just need to change the name of our target view. And so in this case, as long as we land here, we could stop the test right now. Run all of them. Okay, something failed. So let's see, what did we fail on? All right, live debugging. This is real life happening.
This is how it happens.
Yeah. Flow did not expect view. We expected export. We expected the sig type, but we got unhandled exception. Oh, there was an error. Something. Okay.
Not
So when we back out here. I suspect what happened. Oh, I know what happened. I didn't finish modifying this view. Got it. The debugging here is not that helpful, but generally when I've seen this issue of a conflict between greater than versus or less than versus magic mock, what's actually happening is the screen class is still trying to instantiate itself, and it's just running into trouble. So the step that I missed, okay, I made these available. Great. Good on me. But if we look back at our notes, um, let's see. View.run screen is new. I did not update that in this view that I was just altering. So the change that needs to happen is I'm literally, yeah, this is the problem. I'm literally still instantiating the screen and calling display right now. That does
Right.
not work.
Yeah. Yeah.
I can't do it that way. I need to
No.
self dot run screen. The first argument is which screen are we running? What's the class? And then the screen's usual argument. So let's back up again. So this was the original call. So I made it so that it's as easy as possible to modify these to be compatible. So we just have to invoke run.screen. We pass it the class of the screen as the first argument, and then the rest are the normal input arguments for that screen, and we no longer call display. So that's it. It's like, kind of slightly tweak 2.5 lines of code. And if I'm right, hey, all right. So it was just that change. I have to invoke run screen. And actually, if you look at the definition of run screen, that's also why it has this ** kwargs, because those are all the other possible input variables, input arguments for the screen. And so they just get passed straight into the screen class that we're instantiating. It's one of those like kwargs Python magic that I never understood for my first 5 years in Python.
Yeah.
So
I have a question.
Okay, so
If this
yeah.
is a good point to ask one, I don't know
Yeah,
if it is.
yeah.
If we had persistent settings on, and we had, as an example, disabled the xpub export feature,
Yeah.
would this test fail?
Yes. So let's see if we can
Mock that up.
do oops. Yeah, that's a very good question. All right, so now we're going to do export xpub skip what is it? Sig type. All
Yeah,
right.
yeah. I guess there's a bunch of different setting options, right? You can skip sig type, you can skip
Exactly.
script types, but you can also just completely disable xpub as well, or xpub export. But anyway, yeah.
Right. So let's see what GitHub Copilot suggests for a doc string. Selecting export xpub should enter the xpub flow, and yeah, that's pretty generic. That's not a great job. Okay. We still need to load a finalized seed. I'm going to borrow from the settings stuff. Let's see. Well, before we do this, let's look at just the settings test.
Yeah, cool.
Test persistent settings. So we're going to pick one specific setting to save. Oh, no, it's these setting persistent settings. Okay. The settings file should not exist because persistent settings have not been enabled. We run our sequence, go to settings. So we're going to select our the whole settings code structure is like a little more complicated than you would think it would have to be, but it's just kind of a complicated thing. So this settings entry encapsulates all things having to do with the persistent settings. And the display name is how the button data is organized. So we're selecting the settings option for persistent settings. And then the update view, we're going to say, and again, this is all settings make everything complicated. Select the option for enabled. So basically return the enabled option. Hit the back button to exit settings. We should be back in the main menu view. Stop the test. Okay, all we've done was enable persistent settings. Now we assert that the settings file does exist. So that's the entire test. So sanity check, assert that the file does not exist, activate persistent settings, and then assert that the file is there now. and then like the multi-select settings, so like which controllers you support, or coordinators rather. Um, we can we can there's just a whole sequence of selecting and unselecting a whole collection of them. Um, and yeah, I don't know that this is even the best test. And then just because the IO test is within settings, it's kind of trivial. There's nothing that we can really test because it's all hardware stuff. Um, it's literally just testing that the donate, that the IO test and the donate view appear, and that when you exit them, you go back to the settings menu. Those are very trivial tests. Some of these are just for since the coverage was also integrated. So what is it? Coverage run dash m test coverage report. So then within our settings views, we're at 76% test coverage by going through all of this. Whereas if I were to take out the IO test, let's say, and the donate test, let's do that again. Settings has fallen to what, 71%. It was at 76 before. So the fun thing about having the coverage report is that it kind of gamifies testing. So the game is get as close to 100% as you can. There we go. Woo! So you can kind of look like, hey, PSBTs only have 12% test coverage. That's not important, is it? Yeah, so you can kind of just, it'd be kind of fun to have the new developers just take a look at like, okay, where's our coverage lacking? Can you start filling in the blanks? And then while we're here, actually, let me show you something else that's pretty cool.
I mean,
Oh no, how do I get there?
if you get to 100%, then you can have that badge on GitHub, right? So.
Not going to happen. I mean, we're mocking out the screens, right? So that's just it's
Yeah.
not possible.
I know.
There's a badge for that.
Isn't there? I've seen like code coverage badges on GitHub. I don't know.
That's awesome. That's impossible. Yeah, because you have to mock some things. Hang on, I'm just looking for SeedSigner. I just want to show you the coverage HTML output. If you guys haven't seen that, it's really cool. Oh, and let me update it here. So if I already ran. So this command reruns the test and accumulates the coverage and calculates it. Coverage report is just spitting out the raw results. And then coverage HTML generates the interactive HTML output, which is awesome. So let me zoom this up. So it's the same report, except we can now click in and you can see like the exact lines of code. So red has not been tested. There's no test coverage for red. And yellow, I'm not quite, yellow is partial. Like it evaluated that selected button was not none, but because selected button was not none, it never ran this portion. So it like considers that only partially evaluated. It evaluated the fails case, but never went through the success case. But yeah, it's just really cool. And so like, when I ran the coverage and it was like, oh no, these are red. I was like, okay, let's get the red out. So I wrote a really simple test to cover it. Yeah. So it's just really neat. Something like I don't even seed storage. Like validate mnemonic. There's no test for validate mnemonic function. But yeah, it's just really neat. It just, like I said, it gamifies testing. It makes it kind of fun when it's normally not fun at all. Okay, but yeah, I feel like I'm kind of running out of steam here. But did
So if
that?
we just jump back to where we were before we looked at setting up that new test to test whether the persistent settings would be
Okay.
saved.
So yeah, so in this case, so I kind of bailed on setting up the test that Nick suggested because um it's probably not that hard to write, but we would have to um in the setup for the test enable, well, not enable persistent settings, but at least enable or rather disable whatever option we want to in settings. And I don't think I can like navigate the settings um like
Yeah, in real time. I understand.
yeah, like it's such a complicated part of the code.
Yep.
Like I don't even know. Um,
I was more of just
yeah,
thinking, I wasn't even necessarily thinking of instantiating the settings here in this test. More of, I think my question was like, imagine I have a settings.json file, right, locally. When I run py tests, is it going to actually read in that file, or or would it ignore it completely, or would the py tests have its own settings.json potentially? And does that make sense?
that's a yeah. I think I mocked. That's a good question. I
I can
don't
always just
think I
test to
handled
find
that.
out. But yeah,
Um, well, also, yeah, it may be because sorry, hang on. Let me look at the settings.
because it should be relative path,
Here
right?
it
So
is.
yeah,
Settings
exactly.
file name, else settings.json. So yeah, so well, let's see. Does that mean I have a settings.json sitting in here?
I didn't see one.
Where would it be? It would be in either
Wherever
the
you ran
test.
py tests.
Yeah, well, it would be in the root because we're running tests from there. And
Okay.
I feel like I handled that case somewhere. I feel like I mocked that out, but yeah, that's a good point. I don't see it. Um, let's see if there's anything that handles that. Oh, there it is.
There
Hey.
it is. You did.
Yeah,
Cool.
yeah.
Cool.
Oh, it's nice. It's nice when it turns out I thought of things.
When past you remembers things that future you didn't.
Yeah. Although that may have been there before. I don't even know if
Oh,
that's
okay.
new or not. Yeah. So maybe that was somebody else being smart and I just took credit for it. I'm not sure. Um so let me just look back at the PR. So it's a huge PR, but partially because I wanted to write enough well, not example, they're real tests, you know, like testing the seed flows, testing the settings possibilities, testing some of the tools flows, like the address explorer, um, just to see, like, I needed to write a bunch of these to run into edge cases. And so I was like, oh, I have to handle these redirects differently, or oh, I need to inject, I need to modify the view before it actually runs. Um, and so a lot of these have been written, but every view that's being touched in here, for the most part, no, for 100% part, every view that's in here has to have the matching modification um, to update itself to this new universe where these options are at the class level and we're calling run screen instead of directly instantiating the screens and calling display. So if we look at what actually changed, um, a huge amount of the changes are in the view files, but it's really just the same modification over and over again, just to make uh, those options available and to add the run screen call. So, and you know, this overall approach is introducing so many new concepts in the first place, and all of these like mocking and patching, like I was vaguely familiar with them, somewhat familiar with them, but this is much more involved and complicated than any patching I've ever done in the past. Um, and so it did worry me that there's so many things changing in here. Just the basic testing approach is really important, but then it's ending up touching and altering all these other files. Like, look, there's enough changes in seed views that GitHub doesn't even want to view them by default. But the changes should be very light. It shouldn't be anything that, you know, causes any consternation, let's hope. And it's more like the core changes in controller to support what we need it to support, the core changes in view, which are fairly limited. It's just breaking up, those run steps. And then just looking at all these the different test flows and what approach they're using to go through this. And then the other thing, breaking the requirements into two. So in order to run this on my MacBook, I need to install most of our dependencies, but pip will fail if I try to run pip install these RPi packages. So they're now split in two, where the Raspberry dependencies are on their own and everything else is in the main requirements file. And with some updated notes on the manual build steps. Oh, and then this also, the PR mentions that it depends on two other PRs. And one of them is just the explicit support for or requirement to run on Python 3.10. So the instructions update that. And that was just a bug for in a bad include or a bad import that you cannot import on off of a Raspberry Pi. And so once these are merged, especially this one, I think the documentation changes will go away. Because this is built on top of that PR. So there's no reason that this Python 3.10 stuff needs to be within this PR. It's just because it's a child of that PR, that documentation PR. And then there should just be one mention about the two pip files somewhere. There we go. Requirements.txt and requirements Raspberry. So that's really the only change that needs to be in here. Okay. Anything else? What I don't know. Do we have a ballpark figure on what level of mastery comprehension you guys are feeling at for this?
I think this is very awesome. A good review of the PR. Very useful for me. I think staring at the text without some of the context and the why would have been really hard to go through. So this is super helpful for me. I think it's awesome. I think the only question I have remaining would be where do you want to stop with this PR, right? You could just keep on going, right? Building more tests, right? But I'm assuming at some point, as an example, you don't have any tests for the PSBT views. So,
right.
Would you want to include those, or would you want those to be an additional PR? I wasn't sure what your thought was there.
Yeah, I want this approach to be reviewed and merged as soon as possible, and then have subsequent PRs to continue rounding out the coverage. Even with knowing that something like the PSBT flow may require further tweaks to this base, flow test class. Like maybe it's got some extra edge case that I didn't handle yet. But I would say for everyone who's willing, write at least one new test flow using this system. And basically, I I think you could issue it as a PR into my repo. And if I merge it, it would then automatically be added to this SeedSigner PR, so that we can add your new test flow into the actual thing that gets merged. Um, just so that as many people as possible have like hands-on experience writing one of these flow-based tests. Because I think that's the only way to like really get familiar with it. Um, and uh, realistically, I think there's maybe 2 or 3 people total that could go through that exercise or would have the time or the willingness to do so. Even to watch this, like we're at like 2 hours. I didn't think we would go this long. Like that's a big ask. Like, okay, watch a 2 hour conversation about code and then go write code yourself. But I yeah, I at a minimum, Nick, I'd like you to write a test or two. And it doesn't have to dive too deep. And you could even like we started writing a test.
Yeah.
And just kind of be like, let's see, you know, whatever the test is, blah blah blah, and be like, to do this should keep going, blah blah blah. But like, oh look at GitHub Copilot is suggesting something here.
But it's not.
Yeah, so yeah, and just to because like once you've gotten out of the exercise what you wanted to get out, like just stop there, even if the test isn't complete.
Mhm.
Yeah,
Yeah, I
and
completely
then
agree with your approach to what you described. It's more about the concept and making sure that the developers are all on the same page of moving forward, of building views and test flows in the test suite this way. I
yeah,
love it. Sounds great to me.
and then also just sanity check that we didn't break. Like on the one hand, it's like how could we have broken anything if the flows are working? But
Mm.
I mean, we'll still need sanity checks of like just actual, running this code on an actual device and making sure that these changes really are completely innocuous to the main execution thread.
Yeah.
Yeah, because this is the first iteration of putting in that code flow testing, and so we're not making fundamental changes to the way in which the code base runs, but it is the first time that we're putting those calls in.
Right. And I mean, there are, and who knows, like maybe actually the biggest risk is like in here, as you're modifying the views to be compatible with this new approach. Like for a very simple view like this, like, this run is basically doing almost nothing, right? It's just routing. It's just show the user 2 options, return which option they selected. But for a more complicated view, screwing around with some of these what used to be local variables might screw something else up in the view that's more complicated. So there is still that risk.
Fair point.
So, all right. Yeah, we'll wrap it up. I'll post this to YouTube. It looks like we were safely docs free. I'll stop the recording. More